Hey guys, this is Mr. Mitchell. Today we're going to be talking about density. So at this point we've talked about mass, we've talked about volume. We said that they were the two properties required for something to be considered matter. But unfortunately, individually, they don't help me to identify what substances are, what the substance is made of. So think about this old riddle, what weighs more, a pound of feathers or a pound of lead? So we're talking about pounds here, but even though mass and weight are different things, they are proportional. So we can kind of use this when we're talking about mass as well. Just because I happen to have a pound of lead and a pound of feathers, that doesn't mean that they're made of the same thing. Obviously, lead and feathers are two completely different substances. So the mass of those is not telling me what the substance is made of. On the other hand, right, if I just had two objects where I knew their volume, that's not going to help me identify the substance either, because let's say a soccer ball and a bowling ball. Well, a soccer ball and a bowling ball are roughly the same size. They occupy the same amount of space. They have the same volume, but they're two completely different substances. So mass and volume by themselves don't help me to identify what a substance is made of. Really, when we look at lots of physical properties, they're not going to help me identify what a substance is, right? If I'm looking at mass or volume or size or color, right? Just because something's red doesn't mean it's the same material. Just because it's the same size doesn't mean it's the same material. So I have an apple, I have a pool ball, I have a rose. They're all red. They're not the same, right? They're all about the same size. They're not the same materials, right? They're all very different. So in order for me to conclusively figure out what a substance is, what I can do is combine, right, a couple of these properties together to figure out the identity of an object. And when we combine, we come up with this thing called density. So the two properties we're combining are mass and volume, like we started with. Density is defined as an object's mass per unit volume. So simply put, it's just a measure of how much stuff, right, how many particles there are in a certain amount of space. So I have these two boxes down here, right? They're about the same size, but they have two completely different densities. So the one on the left, right, has a whole lot more particles jammed into the same amount of space, and so it would be said that this box on the left has a higher density or is more dense than the box on the right because there's more mass inside the same volume. So we'll go back to our quick example of the soccer ball and the bowling ball. The bowling ball is denser than the soccer ball because it has more mass. Even though it's the same size, it's got more mass packed into its volume. And so it's denser than the soccer ball is. So we can't get away without doing some calculations here. Since we're talking about mass per unit volume, density is mass per unit volume, that's how we defined it. That per is going to indicate to me if I wanted to calculate exactly what a density was, I would divide the mass of the object by its volume. So when I divide those two numbers, I'll get another number, and that is what's called the object's density. So just do a quick practice problem here. What is the density of a 29-gram piece of metal that has a volume of 45 milliliters? So let's go back to our physics days here. We're going to write down the givens that we know up front. So I know that the mass of the object is going to be 29 grams. And I'm given that the volume of the object, capital V, is 45 milliliters. And I know that the equation, because I'm trying to find the density, right? The density equation is mass divided by volume. And so when I plug those numbers in, density is mass divided by volume. The mass is 29 grams. The volume is 45 milliliters. And when I divide those two things, I get 0.644, and that's actually 4 is repeated. And the units, I divided grams by milliliters, so my units down here are be grams divided by milliliters. All right, so that's my solution. I've just solved for the density of that particular material. Remember that I'd said earlier that we could measure volume in either milliliters or centimeters cubed. And so if you were doing another problem where you happen to have a volume in centimeters cubed, remember we said they're the same thing. So you could also say that this is 0.644 grams per centimeter cubed, and you'd still be fine. So we can also take this a step further and say, okay, if I have a bunch of known densities for materials, I can now calculate the density of an object that I don't know the identity of and figure it out by comparing it to a table of values. So I have just a table of 3 values here, iron, lead, and platinum, and their different densities. So I want to know the identity of a material that's got a mass of 296.02 or 06 grams and a volume of 26.2 milliliters. So what I'll do is I'll just calculate the density of this one. Remember, it's mass divided by volume. So the mass was 296.06 grams. The volume is 26.2 milliliters. And when I divide them out, I end up with 11.3 grams per milliliter. Well, if this object has a density of 11.3 grams per milliliter, and I happen to know that lead always has a density of 11.3 grams per milliliter, then I can say that this object is certainly a piece of lead. All right, and so that's how, it's kind of a nifty way where we can identify substances. I could pull a material out of a box and say, well, I don't know what this is, but if I can find its density and compare it to a list of values of densities that are known, then I can identify what that substance is made of. Another application of density is it's the determining factor of whether something will sink or float in another substance. So two substances, I mix them together. The one that's got a higher density, more particles packed inside, is going to sink down to the bottom. And the one with a lower density, that's kind of more spread out, will float up to the top. So I'm sure you've seen, oil and water mixed before. Oil and water don't want to mix with each other, and the oil tends to float up to the top. Well, the oil floats to the top because it has a lower density than the water does. So the oil particles float up to the top, and the water particles sink down to the bottom. If we want to look at the numbers of this, right, we know that water has a density of 1 gram per milliliter. So a tennis ball, for example, I throw a tennis ball in a lake, I know that the tennis ball is going to float. Well, the density of a tennis ball is only 42 or 0.42 grams per milliliter. So that's much lower than this 1 gram per milliliter. So what happens? The tennis ball, since it has a lower density, will float to the top of the water. Now, if I compare that to a 12-pound bowling ball, it's got a density of about 1.03 grams per milliliter. So it's only over 1 by 0.03. But that is still enough to show that that bowling ball, since it has a higher density than water's, which is 1, it will sink down to the bottom of the water. And so to take it, a couple steps further down the line, we have these density columns. If you Google it, you'll see all sorts of things. And I've seen much simpler ones. This is probably the most complicated density column I've ever seen. But the premise behind this is that anything that has a high density will sink to the bottom, anything with a lower density will float up to the top. So as I go down the density column, I get higher and higher densities. So the bolt that's all the way at the bottom has the highest density of anything in this column. And the ping pong ball, it's floating on the top of everything, has the lowest density. So let's pick two things out of here. Dye is sitting here, and then a popcorn kernel is there, so the popcorn kernel is underneath. It means it has a higher density than the dye does. Or maple syrup is here and corn syrup is below it, means that maple syrup has a lower density because it's on top of the corn syrup. All right, so that's just kind of a cool application there. Why does an object float? It has a lot to do, or has everything to do with the density of the things that you're mixing together or putting inside of each other. So that's all we have today on density. Hopefully this is helpful, especially as you go into that next phase of your lab. You're going to make some calculations and hopefully be able to identify some substances just like we did here today.